All right. Welcome back to the second edition of Section 6-1 Notes. Here's the work that I was trying to explain. You guys read that while Cal tells me something. Okay. All right, so moving on. Backside of 6-1. All right. Exterior angles. So on the front was interior angles. Now we're talking about exterior angles. So how exterior angles are created. They are created by extending kind of in one direction. Gets me every time. One direction. You guys, I don't even know if you guys know what that band is. So if I take side AB and I extend it, I've created this exterior angle of, we don't have a third point here, so I can't say what this angle would be, but here's the exterior angle, okay? So now if I started at A and I extend out, and I'm kind of going in this clockwise manner, and I keep extending out, there is a kind of a circular motion, right? I'm making a full rotation around this shape. And we know that circles have a, hopefully we know this, I don't know, maybe not. Circles have degrees of 360, right? A whole rotation is 360 degrees. So that's it. There's no like special side rule. Literally, no matter what shape you have, the sum of the exterior angles is 360, okay? No matter how many sides. So I don't even have to look at this. I just say the sum of the exterior angles. Literally, it does not matter how many sides. 360, 360, 360, okay? Very simple rule. And again, it's because you have to do it like in the one directional manner, okay? I can't go this way with AB, but then this way, right? It's got to be one rotation, okay? Any convex polygon. Okay, we just said that. Example 2. Find the measure of each exterior regular. Again, there's that regular. So again, now it's a little bit easier because remember on the front, you had to find the sum first to be able to divide it equally. Well, here, you know the sum. There's no formula for it. It's literally just 360. This is now coming back to me as to why we can do 2 sections in one day. So, hexagon, hopefully you guys checked out that page 394. Hexagon has 6 sides if you didn't know that one already. Heptagon, lucky number 7, right? N equals 7. So we take 360 divided by 7. And so we're going to start to see some angles that don't come out perfectly, and that's okay. Do not round, all right? Take it as far as it needs to go. Most of the time it'll be, 1 or 2 decimal places. Now I say that, and maybe we should round this because I don't know that doesn't say to round. So let's see. 360 divided by 7. Oops, that's 36 divided by 7. Yeah, definitely rounded. Okay. I would say 10th. Round to the 10th, unless otherwise specified. Okay? That's a safe decimal. Dodecagon. Anybody remember from the other side what it was? That's right, the old dozen. 12. 360 divided by 12 equals, bada boom, bada bing, 30 degrees. Okay, octagon we've already done. Again, what's the pattern here? We don't need to do 100 of these to know that it's take the sum, divide it up equally if it is regular. Okay, regular, consistent, the same every day. All right, section 1 done. Section 2, what's new? Parallelograms. All right. What do we know about parallelograms? Well, let's look at first what the definition is. Okay, so remember there's going to be all these theorems and all these if-then statements, but those are different than the definition. Okay, so it's really important to know when do I use definition of a parallelogram and when do I use if a quadrilateral is a parallelogram, then blah, 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 blah. Okay, so a quadrilateral with both pairs of opposite sides parallel. is a parallelogram. So if you have any statement besides naming PS parallel to QR, PQ parallel to SR, if it says anything besides those two pairs of opposite sides parallel, you're not using the definition, okay? The definition is about the two pairs of opposite sides parallelogram, okay? Opposite sides parallel. So, now, PQRS is a very specific 4, right? So that takes care of the quadrilateral, right? 4. That was probably on that polygon chart, okay, from last section. Oh, looks like there's something missing here. What is missing? Yeah, there's an SR missing here. Sorry about that. Okay, so if you have a quadrilateral that is a parallelogram, because by definition, parallelograms are quadrilaterals, okay? Then opposite sides are congruent, okay? PQSR, PSQR, okay? Congruencies, you're probably going to want to have the order correct, but it doesn't, with the sides, it doesn't really matter whether you had PQ or SR or PQRS. I don't think it matters. I hope this isn't too distracting. Hey Cal, can you cut down on the giggling? It's not that funny, is it? Not sure if you guys have ever seen Hercules, because I think it was from like the 90s. Alright, I gotta pause this. Sorry guys. He cannot stop giggling, so I'm going to try to be quick here. Alright, so you can start marking things up. Equal, equal, right? Opposite sides are congruent. Second characteristic, opposite angles are congruent. So P and R, right? S and Q. Now we should know what these all total to as well, because it's a four-sided figure, right? Oh gosh, the video didn't pause again. Oh, I'm sorry guys. I know the video's paused because I'm waving my hand and I don't see it. Alright, on to video number 3, I guess. One more try? Anything? Anything? No, dang. Okay.